Hello everyone, welcome to this tutorial. In today's lecture we're gonna see, first we're gonna review on how to measure an angle and what is quadrant and how we identify, and then we're gonna we are going to see what is radians and how to measure angles in radians. After reviewing on this concepts, we will see the introduction part of the basic trigonometric functions, and then we will use these definitions to find the trig value of using unicircles. So in this lecture it is expected one able to measure an angle in degrees and radians, and also find sines, cos and tan value of quadrantal angles. We will see what are quadrantal angles later on. As introduction, trigonometry functions are simply functions of an angle, and we can loosely translate trigonometry as a measure of triangle. Let's see what the basic terminology on this issue. In measuring of an angle, the start of an angle is called initial positions, and the end positions of an angle is called terminal positions. For any given angle, it have initial positions and terminal positions. The initial positions is the starting, while terminal positions is the ending positions. So in our case, this OA is initial positions, while OB is terminal positions. If we measure an angle in counterclockwise direction, then it's taken as positive angle, but if it is in clockwise direction, so it is negative angle. When we say clockwise, it means it rotates like a clock in our hand. So for example, here beta is clockwise direction, so its value will be negative, while this is counterclockwise, that means anti-clockwise directions, and also this delta is anti-clockwise directions. So for this gamma and delta, they have positive value, while beta is negative value. After seeing how to measure these values, let's see what are quadrants. Simply, in xy coordinates, for both x and y are positive, we call it is quadrant 1. If x is in negative direction and y is in positive direction, it is quadrant 2, and if both of them are in negative directions, it is the angle lays, we call in quadrant 3, and if y is negative and x is positive, then it is quadrant 4. So this is how we identify the quadrants of an angles. But first, let's define what is standard position. In measuring of an angle, we will use standard positions. Standard positions means its vertex of an angle is origin. So if its vertex is origin and the initial position is positive positive x-axis, so we call it is standard position. So for every angle, the varies is only on its terminal positions, since its initial positions is fixed to positive x-axis and its vertex is fixed to its origin. So in our case, for example, this is lays in first quadrant, this one is in second quadrant, while this one is third quadrant, and this one is fourth quadrant. In measuring of an angle, not only degrees are usable. Scientists, engineers and mathematicians usually work with angles in radians, and we have to define what is radians. If the angle theta is subtended at the center of a circle by an arc length equal to that of its radius, then we call it is 1 radian. So when we say 1 rad, we say that the angle theta subtended at center by equal arc lengths. So in our case, for example, here, if the radius of a circle is r, and if the angle subtended by the circle is arc length is r, the same as its radius, thus then this theta is 1 rad. If generally, if it is S, then we can find theta as S over R radians. For example, if S is, for example, here 5, and for a circle with a radius of 2, then theta will be expressed 5 over 2, which is in radians. If, for example, if it rotates one full cycle, one revolution, so 360 degree, and it can be expressed this circumference using the formula 2 pi r. So 2 pi r over radius r, it gives 2 pi radians. So one full revolution means the same as 2 pi radius. Okay, after defining, let's see how to convert degrees and radians, degree to radians and vice versa. To change degrees into radians, simply multiply by pi over 180 degree, while to change radians to degree, multiply radians by 180 over pi. Let's see some examples. For example, 30 degree can be expressed in radians by multiplying pi over 180 degree, and by 30 it will be 1, by 30 it is 60, so pi over 6 is the same as 30 degree. The same way, 60 degree can be changed into radians by multiplying pi over 180 degree, and we can get pi over 3 radians. For 120 degree, so we multiply 120 by pi over 180 degree, which gives 2 pi over 3 radians. To change radians into degrees, we will use by multiplying 180 degree over pi, so 3 pi over 2 times 180 over pi, which gives 270 degree. The same way, pi over 4 radians can be expressed in degree by multiplying 180 over pi, which gives 45 degree. Then, till now, we review how to measure an angle, what is quadrant, and how to measure in radians. Now, let's see what is basic trigonometric functions, and after defining, let's see how to find value of trig values. Sine, cosine, and tangent functions are the three basic trigonometric functions. Let's consider a right angle triangle. ABC is a right angle triangle. So for a right angle triangle, a side which is opposite to right angle is called hypotenuse, while the side which is opposite to the angle is called opposite, and the side which is adjacent but not hypotenuse is adjacent side. For theta, in our case, AC is our adjacent, BC is our opposite, and AB is our hypotenuse. For this case, if phi is here, then our hypotenuse is simply this one, unchanged, but the opposite side will be AC and the adjacent side will be BC. After knowing this, let's define the basic trigonometric functions that are sine, cosine, and tangent. If theta is an angle in standard position, meaning standard position, so it have a vertex of origin and initial positions at positive x-axis, then, and if a point PAB with radius, it have a distance of r from this origin, so if it have a distance r, so the hypotenuse of this one given r, then we can define sine is simply defined as opposite over hypotenuse of this angle. The opposite side is simply b, and the hypotenuse side of this angle is r. The same way, cos theta is defined by adjacent over hypotenuse. The adjacent side of theta is OQ, which have a length of a, and its hypotenuse have a length of r, so a over r. The same way, tan theta is defined opposite over adjacent, which will be b over a. Remember, a and b are a point which are given, but we don't know r. So since OPQ this triangle makes a right angle triangle, we can find r using Pythagoras theorem, as r will be radical a square plus b square. Sin theta, cos theta, they are simply abbreviations, and the input of the Trig functions are simply an angle, and the output will be a number. Let's do some examples. For example, if P is 3 over 3,4, a point 3,4, which is in standard position, let's find sine, cosine, and tangent of this. First, draw this one, 3,4. Then, since it is in standard position, it have an origin of 0, 0, and its initial position is this positive x-axis. So, after drawing this right angle triangle using the definitions of the basic trig functions, we can find sine theta opposite over hypotenuse. Its opposite side is this one. This have a length of 4, and the adjacent side which have a length of 3, and r can be found using Pythagoras theorem as 3 square plus 4 square radical, which gives 5. So sine theta, cos theta, and tan theta will be defined from the definition using the definitions as this one. Okay, now let's find the trig value of some functions. For that, let's first define what is unit circle. A unit circle is a circle which have a center at origin and a radius of 1. For such kind, if this is a unit circle, using this unit circle we can find sine and the basic trig value of quadrantal angle. Quadrantal angle is an angle which whose terminal side lays on x or y axis. For example, if the terminal side is this one, for example here y axis, then it is quadrantal angle. If the terminal angle lays on this, for example, it will be quadrantal angle. We can use the equation of circle, that is x squared plus y squared, which gives r squared. But now let's draw simple right angle triangle from this, a point P arbitrary on a unit circle having a point x and y. So for this point it have y length and x length, which is adjacent to this theta. So for a measured theta we can find the sine. So sine will be opposite over hypotenuse, so its opposite is y and its hypotenuse is r. In our case r is 1, so y over 1 is simply y. So sine theta will be the same as y for a unit circle. For cos theta it will be x over r, which is x. For tan theta opposite over adjacent will be y over x. So using this definition, let's find some angles of quadrantal. Okay, let's find the trig value of theta, which equal to 90 degree, 180 and 270 degree. 90 degree, first let's draw. 90 degree means, since this is the initial, if it is standard position we will use standard position, so this is the initial position, and from this 90 degree measuring it gives y direction, so positive x, positive y. So since it have a unit of radius of 1, so it have 0, 1 at this point, and 180 will be this one, and 270 degree means the same as this one. So applying the definitions of this one, so sine 90 degree means y. So our y, the measurement of y is, it will be 1, and cos 90 degree it will be x, so our x is 0 because 0, 1 is a point, so it will be 0, and tan theta y over x, which is 1 over 0, undefined, so it doesn't exist. For sine 180 degree, so 180 degree, so it have a measurement of in negative direction, so negative 1 0 this point. So after getting this negative 1 and 0, you can find sine 180 degree, which will be y is 0, and cos 180 will be the same as x, which gives negative 1. The same way, tan 180 degree gives y over x, which is 0 over negative 1, which is 0. The terminal angle of 270 degree gives 0 negative 1. First, the point 0 negative 1, since this radius is in negative y direction, so the point will be 0 negative 1 here. So using this 0 negative 1, we can find these angles. As exercise, try to do this, and we will have discussions on these issues. For now, it's enough. Lecture 2 will be on special angle, how to find special angles, basically 30 degree, 45 degree and 60 degree. So for now, do this exercise and wait for lecture 2.